Okay, so what was the question? The quiz question was 24x to the 7th minus 12x to the 5th over minus 4x to the 7th. Okay. All right, so how do we do it? What do we do on this problem? What do we do when we have that big old bar like that big old fraction thing? Yeah, means division, divide by both of them, huh? Two separate divisions. You can just do it like that. You don't have to rewrite it. I'm just going to rewrite it. I'll go down here. You go sideways, whatever. I'm going to rewrite it as two separate. You don't have to. You could just do it as it sits there, you know. So I'm making it two separate. But do you see all the signs there? Excuse me. Excuse me again. That minus sign went right there, huh? The subtraction, and then the negative is on the bottom for both. On that. So the negative is on the bottom for both, and then the subtraction in the middle. So, and then we divide these two, and we divide these two. So when you divide, remember the rules for dividing. You divide the numbers in the front, right? So 24 divided by 4 is 6. Going to be negative, huh? Because it's got one negative sign there. And what happens with x to the 7th over x to the 7th? Totally cancels. So it's just x with nothing, right? No, don't do that. That's a common mistake I see, right? X with nothing really means x with 1, right? There's always a divisible 1, and that'd be wrong. That's not 1. 7 minus 7 is 0. So they're gone. The x to the 7's totally cancel. Now, in the middle, what sign is going to be here in the middle now? Positive, because the 2 minus is getting together, huh? Everybody good with that? It doesn't matter this guy's in the bottom. Remember we talked about bottom, top, front, it's all the same thing. So these guys are really in the same zone. 2 negatives makes positive, huh? Good like that? Remember, it doesn't matter if it's bottom of a fraction, top of a fraction, front of a fraction. They're all living in the same world. And so they get together. 2 minuses make plus. And then 12 over 4 is 3. And then now the powers are going to subtract. Notice when it comes to the 12 and the 4, the bigger 12 is on the top, but when it comes to the x powers, the bigger one's on the bottom, so the x2 ends up on the bottom. Remember that? Wherever the bigger is, that goes for numbers in the front or powers, wherever the bigger is, that's where the leftover ends up, huh? So if the bigger front number, 12, is on the top, the leftover 3 is on the top, when they, 4 goes into 12 3 times. And if the bigger power is on the bottom, then the subtraction power ends up on the bottom. Huh? Like that. Is that good? Does it all seem easy? Can you do that today on the practice exam? And then, most importantly, tomorrow on the real exam? Questions that I can answer on that one. All is well? All right. Even if you got that wrong, you get 5% just for clicking and being here. You get half credit for the quiz even if it was wrong.
I don't understand because I take 5 to minus 7, so I got minus 2.
Yeah. Okay. Good. I'm glad you're asking that. So, let me say 2 things. Yeah, good question. So what she's saying, she's saying, look, 5 minus 7
And I got minus 2.
is minus 2. And you're totally right. What I'm saying, so let me say it 2 different ways. What I'm saying is you should start with the 7. Start with a bigger one, wherever the bigger is. So if the 7, the bigger, is on the bottom, start with that one. 7 minus 5 is 2, and the answer goes in the bottom. Does that make sense? So you start with the bigger one. You don't start with the top one, necessarily or always. You start with the bigger one, wherever that would be. So if the bigger one's on the bottom, start there. Now, you can do it your way, actually. I like what you're saying, because all the rules in math agree, which is always good. You could start with the top. That technically is okay. X to the 5 over x to the 7. 5 minus 7 is negative 2, like she's saying. But if I do it that way, who am I starting with? The top. So really, the more technical rule, I try to make the rules simpler because there's so many rules. But if you want to know like the real story, you actually can start with either one you want, top or bottom. It's just whomever you start with, that's where the answer goes. So if I start with the top, 5 minus 7, negative 2, that goes in the top because I started with the top. So the answer would be negative 2 on the top, and then what did we learn about negative powers? Then it would jump to the bottom, and you'd end up here anyway. Does that make sense? So I'm just saying, to make it simpler, I'm just saying, hey, just start with the bigger one, and wherever the bigger one is, that's where the answer will end up. It'll be positive every time. You won't have to mess around with that extra step.
But you could easily end up minus 6 plus 3x minus 2.
Yeah, minus 6 plus 3x minus 2, like that. That's true also. Now, they're never going to want us to leave negative powers. So we'd have one more step. Jump it down. Right. That's another way of saying that. Yeah, good. You guys are getting it. That makes me happy. All those rules are fitting for you, right? Hand in glove. They're making sense. They're all agreeing with each other. Good. So there's the form they want. All right. Well, the game plan today's practice exam day, right? So we're going to cover 3.1 first off, and that's not on tomorrow's test. That's part of exam 3, right? If you look at your syllabus, that's which is just next Monday. It's never far away here in the summer. Next week is a 2-test week. 2 exams, one on Monday, one on Friday. Wow. And so is the week after, because we have the one in the middle of the week and then the final at the end. So this is the last 1-test week. The next 2 weeks are 2 tests each week. Wow. This is a wild ride we're on here. All right, we're going to cover 3.1. And then we're going to take, maybe till about 8:30 probably. Then we're going to take practice exam number 2 for an hour, maybe to about 9:30. And then we'll go over practice exam number 2. Make sure you understand everything for the rest of the time, to about 11. And that's our plan. All right. Get you ready for tomorrow's main attraction. 2 as well. We may not get all the way through 3.2, but we'll do a little bit of it. There we go. So we'll do some 3.1, some 3.2. Just do that till about 8:30. Then we need to start taking our practice exam and going over our practice exam. Was it locked? Come on. Didn't need to lock it. All right. So, okay. So we're solving equations there. X plus 8 equals 9. We're moving into equations. So you guys are laughing at that one, huh? It's an easy question. So, let's just talk about equations in general. We're moving into the world of equations here. So, now, is this the first time we've had an equal sign? Excuse me. Right? You know what I'm talking about? If you look back at the question we just did, for example, from the from the quiz, there was no equal sign there. Was there? I later put an equal sign right here, but there was no equal sign in the question. So here we have an equal sign in the question, which means there's a left side and a right side. It's a system in balance, right? They're equal to each other. Left side and right side. Equal. Even though they don't look the same. X plus 8 doesn't look anything like 9, does it? They look very different, right? This side does not look like that side. Right? It's like, so it's about equality. Things are equal even though they don't look equal. It reminds me of the old riddle. You remember that riddle, which seemed hard to me when I was a kid. Remember the riddle, what weighs more on the scale? If you're going to put it on the scale, what weighs more? 1,000 pounds of gold, picture the gold, or 1,000 pounds of feathers. Picture that? Yeah, you guys are like, Mr. Herron, that's a child's question. I know, as a child, it confused me, but now it seems silly. But yes, when I was a child, I would be like, 1,000 pounds of gold, 1,000 pounds of feathers. I don't know, that's a lot of feathers. It threw me. But the point of that is, their weights are the same, even though they would look wildly different, right? 1,000 pounds of feathers would look quite a bit different than 1,000 pounds of gold, but they're both 1,000 pounds, right? That's what's true when we deal with equations. These things are equal. This and this, x plus 8 and 9 are equal. That's what you're always dealing with when you're dealing with an equation. They are equal to each other, even though they look different. So, all right, so with that in mind, what is it we're supposed to do with this equality? Well, they want us to get x all by itself. They want us to get x alone. So x is over here saying, I want to be alone. So who does that mean we need to get rid of if x wants to be alone? We got to get rid of that 8 because x is a loner. He wants to be alone. He wants to get rid of that 8. So what am I going to do to get rid of that 8? Yeah, you got to do the opposite of whatever's there. Huh? So what's the opposite of it? Right now it's an added 8. So what's the opposite of an 8 added? Subtract 8 from both sides. Oh, yeah, by the way, why did I just do it on both sides? Because they're equal. Remember, the left side equals the right side, and I want to keep them equal. I want to be able to write equals on the next line. If two things are the same, equal, and you treat them the same, the result will be equal. That makes sense, doesn't it? Right? If two things are equal and you treat them the same, they'll be equal when you're done. Right? Everybody with me on that? If two things are equal and you treat them the same, they'll be equal when you're done. So if this, x plus 8 equals 9, and I subtract, if the left side and the right side are equal, and I subtract 8 from both sides, then on the next, then the results will be equal as well. And what is the result of the left side? What is x plus 8, I'm scribbling all over this thing, minus 8. What is x plus 8 minus 8? Yeah, these cancel, and it's just x. You with me? And what's the other side? 1. And we're done. See what I did? Subtract 8 from both sides. X is 1 is the answer. Now, you probably knew that from the beginning, right? The original equation said what plus 8 is 9. What plus 8? Well, 1. Clearly 1 plus 8 is 9, which is the answer that we found by subtracting 8 from both sides. All right, I'm probably beating a dead horse. You guys are like, we got it, Mr. Heron, we got it. All right, we got it. Let's move on. All right, so x minus 3 equals, there's the wall. I encourage you to put that line in just to make it real clear in your vision. You got a left side, got a right side. The two sides are equal. And x is saying, I want to be alone. X wants to be alone. All right, so how do we get x alone? Got to do the opposite of whatever's next to x, right? What's the opposite of the minus 3? Got to add 3. See how we're always doing that? That way these guys will cancel and x will get his wish. He will be alone. You always do the opposite of whatever's next to x, and you do it to both sides because you got to keep the balance, huh? An equation is a system in balance. They're equal. All right, so what do we get then? The x comes down, the 3's are gone. On the left side, what's the other side? 21 plus 3? 24, and we're done. Good, good. On that. Easy, it's just the beginning of our chapter 3 is all about equations. We'll get messier and messier. So W minus 1.1 equals 1.2. There's the wall. Go ahead and solve for W. Decimals, just use a calculator, or you can do it by hand if you want to, but I think it'd be nice to use a calculator. So W, this time, is saying, I want to be alone. What do we do to get W alone? Yeah, because W has the minus 1.1. The opposite of that would be add 1.1. Whatever you do to one side, you do to the other. This is gone. W equals, now on the other side, what is that going to be? 2.22, right? You, oh, you're right. What am I doing? Thanks. I didn't even notice I messed up there. 1.2. So the result should be 2.3. Sorry. We good? Now? Questions on that? It's all good? Do whatever it takes to get the letter alone. Just do the opposite of whatever's next to the letter. All right, so 5.9 is x plus 1.3. There's the wall. Okay, now, does it matter that x is on the right side? Not at all. X is still saying what he's always saying. I want to be alone. Get rid of whatever's next to me. So what's next to x?
Positive 1.3.
Right. So what do? Subtract. Right? So yeah, don't worry about x left side, right side, whatever. Just wherever x is, go to x, do the opposite. So just subtract 1.3. That'll get rid of that, right? And whatever you do to one side of the wall, you have no choice but to do the same thing to the other. Why? Why do we have no choice? Got to keep the balance, keep the equality, don't we? Equal treatment, fair treatment, both sides. If they were equal before, you treat them the same, they'll be equal afterwards, right? So we get whatever that is, 4.6. And there we go. Is that good? All right. All right, so 2 plus 4 plus x is 1 plus 5. Okay, try that one. I'll give you a second on that one. So we can just add the things like 2 and 4 make 6 and 1 and 5 make 6. First, do that first. Here's the wall. And then x is saying I want to be alone, so you do the opposite of whatever's next to x, which means subtract 6 from both sides. Boom. Like so, and x is 0. There we go. X is 0. Is that good? Questions on that one? Easy so far? Okay, I'm going to make the S into an X. So 4.7x minus 7.6 minus 3.7x equals minus 15.6, and here's the wall. All right, so what do we do on this problem to solve for x? First off, notice we could switch the order. It doesn't matter that there's a 7.6 between those two guys. Those two x's are going to subtract each other, right? Because they're on the same side of the wall. They're both on the left side. So you can rearrange the order if it bugs you. You don't have to. I'm just going to subtract them right now. They're on the left side. 4.7x take away the 3.7x is what? 1.0, or just 1x. Everybody okay so far? You just subtract the numbers on. It's just like terms, right? Let's write that up here. Like terms. That's just like terms. Just subtract those x's. like terms. So far, so good? Now, back to business as usual. Can you finish it from there? X is in and 1 below. You know what to do. Use your calculator for decimals. So to get x alone, you add 7.6 to both sides. All right, now what does that leave us? This is 1.0x. And when you do those in your calculator, it's going to be minus, is it minus 8? It's minus 8. And what is, we're good so far, what is 1.0x?
1x.
Yeah, that's just 1x. 1.0 is just 1, huh? And what's 1 times x? That's just x. Right? 1 times x is just x. Like 1 times anything is just itself, huh? 1 times x is just x. So that's it, we're done. That's just saying x equals negative 8. X equals negative 8. Question? Making sense? Anything I can answer? We all good with that one? So you see how, why did the 1 vanish? Well, because 1 times anything is just itself, huh? Like 1 times 7. You know, if I wrote, pick any number you want, pick 23, you know, well, what is 1 times 23? Just 23. You don't need the 1. The 1, in a sense, vanishes, right? We always have these invisible 1s everywhere because 1 times anything is just itself. That's why we have these invisible ones. So same way this 1 turns invisible because it's not needed. It's not doing anything. 1 times x is just x. So all I did was subtract the x's, get 1.0x, and then add the 7.6 to get rid of this, and that put x alone. Remember, the goal is always to get x alone. X is the big loner. All right. So there. So we have 6 plus 4 is 5r plus 9 minus 4. Here's the wall. So give it a try. R is saying, I want to be alone. So 5r minus 4r. 1r. 5r minus 4r is 1r. Good? And that 1's going to vanish, huh? Because 1 times r is just r. It's going to become an invisible 1. But first, r is saying, I want to be alone. So what do we got to do to get r alone? Yeah, subtract 19. Yeah, because that'll get rid of it here. And whatever you do to one side.
9, not 19.
Am I just? I'm being crazy today, huh? This is bad. I am getting old. It's just, is that what it is? Or am I just getting old? Okay, minus 9 from both sides. There we go. All right. So minus 9 from both sides. These are gone. So then this is 1, and 1 times r, this is just r. You don't even need the 1 there anymore. So r is 1.
So, I think I'm getting confused on, it's addition, and then it turns into subtraction. So.
Yeah, so I added 6 and 4 to get 10? So when you say it's addition, what's addition?
Okay, so the first one is at 5r plus 9 minus 4, and then that's subtracting those.
Right. Which to get 1r, I take 5r minus 4r to get 1r.
I got that. And you did.
And then r is, here he is, he said, I want to be alone. Anybody with me?
It's plus 9.
Yeah, because of the plus 9, I got to subtract it. We always do the opposite of whatever's next to the letter.
Okay.
Yeah, always the opposite of whatever's next to the letter. So the opposite of what's next to that 1r, plus 9 is next to it. The opposite of that is minus 9. So I subtracted 9 from both sides. Good? Does that make sense? We all good there? All right, so R is 1. So we have 3x plus 4 minus 2x is 11. And here's the wall. All right, so go ahead. You know what to do. What do you do with the parentheses, the floodgate wall thing? Walls come down, water rushes out, right? So that 3 is going to distribute. Right, when you drop, on the next line, you're going to drop the walls, you're going to drop the parentheses, and the water that was up against the floodgate, the 3, is going to go through and hit everything, right? It's going to hit the x, hit the 4.
It's like multiplication.
Multiplication. And how do we know it's multiplication? Because the 3 is right up against the wall. In other words, if it was like 3 plus, then it wouldn't be multiplication. But since the 3 is right up against the wall, it is multiplication. So multiply. Three x plus 12 minus 2x is 11. We good to there so far? So that 3 just multiplied. And now the two x's that are on the same side of the wall, right, they're going to subtract.
Yes.
So subtract those two. 3x minus 2x.
X.
That's going to be 1x or just x. You're totally right. You can just write x. You don't even need the 1. It means the same thing. Huh? Either way, just regular x or 1x, same thing. Good to there so far? Just subtract those. And now, x is saying, I want to be alone. Get rid of anything with me. Remember, you always do the opposite of whatever's next to x to get x alone. So what's the opposite?
Minus 12.
Minus the 12. Exactly. Is that making sense on these? And so those are gone. And 1x or just x is what? Negative 1?
Yes.
And again, you don't need this 1. I'll get rid of it. There it is. X is negative 1.
So you use the one on that side, not the,
What's that?
not the 11? You
Oh.
wouldn't use the 11 to subtract?
Well, one more time. I'm kind of old. I need it loud and clear. Sorry.
Like,
You
how you
work
know
on the
which,
side of the x.
yeah, like what side of the X to do?
Oh, are you asking like, why don't I get rid of the 1 like I got rid of the 12? Is that your question?
Yeah, no, like instead of, like, how do you know to use the 12 instead of like 11? I don't know.
Oh, it's whatever is with X on his side of the wall. See, the 11 is on the other side of the equal sign. We're not looking over there, right? Look at the wall, right? X is over here. Who's with him on his side of the wall? The 12. Get rid of the 12. Does that make sense?
Yeah.
It's like if I yelled out all of a sudden, I want to be alone in here. Well, you guys would be like, you're weird, Miss Taryn. We want you to be alone. We're out of here, right? But nobody in another room, right, would leave. If I said, in this room, I want to be alone, it's only the people with me. Does that make sense? So it's whoever's with X on his side of the wall that goes away. Not things on the other side. Does that make sense? Not people in another room. If I yelled out, I want to be alone, people in the other room would hear it and go, that's weird, and I'm not going in there. But nobody from that room would leave. They'd probably shut the door and lock it. Right? So it's only the people with X in his side of the wall that leave. Is that good? Is that all making sense? All right. Let's try this one. All right. Ooh, that's a big mess. So I'm going to make those X's because, you know, X's are easier to read. So 1.8 X plus 4 minus parentheses 6.7 plus 0.8 X equals minus 9 plus 7. It's a big one. Okay, here's the wall. Always put in the wall. The wall is the most important thing. The equal sign is the wall, right? The separator. All right, you know what to do with parentheses, right? It's floodgate. Drop the floodgate. And when you do, anything up against the wall goes in. What's in front of the first parenthesis? 1.8, so that's the water that's going to hit the X bar. What's in front of the second parenthesis? A minus sign, or a -1 if you want. A negative sign is right up against that wall. So that minus sign is going to go to both, isn't it? Just like a number, a minus is really a minus sign up against the wall. So anything up against the wall distributes. So don't forget. So just like the 1.8 will go boom and boom, the minus sign will go boom and boom as well. Right? Anything up against the floodgate. When the walls come down, the water goes in and hits everything. Just like that.
So make that negative.
Make both those negative. Negative 6.7 and negative 0.8x. It hits them both, right? The water goes in and hits everybody. Yeah. So both those. (1.8x) plus, what's it, 7.2 minus 6.7 minus 0.8x. And the other side's just -2, isn't it?
Yeah.
Everybody see that first line? See how those both are negative? Negative 6.7 and negative 0.8x. See how they're both negative? Not just one of them? Like that. Is that good? And now, where do we go from here? Is everybody good so far? The walls are down. The floodgates are down. The water went in. Now, can we put the two x's together and then the two numbers together?
Yes.
So the 1.8x minus 0.8x, use your calculator if you need to. What's 1.8 minus 0.8?
X.
1x, or just x. And then these two combine as well. Plus, is that 0.5?
0.5.
Yeah, 0.5 or 0.5, same thing, the zero's optional. You good to there? So the two x's subtracted, the numbers subtracted. And now what is x yelling out? What is x always yelling out?
Leave me alone.
Leave me alone. I want to be alone. I want to be alone. So we get rid of whoever's with x. I'm not looking over at the -2. That's the other side of the wall. I'm looking at who's with x. Who's with x? The 0.5. That's who we have to get rid of. So, subtract 0.5. Zippo. There it goes. So x equals out, is that minus 2.5? There we go. We got it. Did we get it? How many got that? -2.5 answer? About 60% of you. Questions I can answer on that one?
I don't think I understood where the -2 came from.
-2. Oh, the -9 plus 7.
Okay.
Made that -2. Good. Other questions I can answer? Good. Question?
What happens to the 1.8?
Yeah, so the 1.8, it multiplied x, and then it multiplied the 4. Like that.
Yeah. And
Oh,
then-
like where did it go from here?
Yeah.
Oh, yeah. I see what you mean. The 1.8x and this guy, since they're both x's, subtracted. So you would, on your calculator, you would go 1.8 minus 0.8 on your calculator. 1.8 minus 0.8, I guess it is. So minus 0.8 on your calculator. So you subtract the numbers in front of the x's. Since they both have x's, these are like terms. These are apples with apples, so to speak.
Then what happens to it after that?
So that made the 1x. So when you subtract these guys, you get 1. So we subtract the numbers in the front, and we get 1.
What if we didn't get one? Or like, what if the question that we have is not?
Yeah, we'll get to that in the next section. Yeah, for now, they're always going to become 1 for this section. Is that good? Everything good on that one? All right, so minus 2 parentheses 17x minus 3 plus 7 parentheses 5x minus 3 minus 8 equals 8 minus 5. Okay, so you know what to do, right? Distribute through those parentheses on the left side. Definitely do it. I just skip the tricky ones, you know. All right, yeah. All right, let's take a look. So translate the math into English. Which translation is not correct? I don't know. Let's try the first one. 28 equals the difference of some number and 12.
That is correct.
That's true. 28 equals the difference of some number and 12. Yeah, that's right. What about part B? 28 is 12 less than some number.
That's right.
Then that's also right. That's what this is saying, right? 28 is 12 less than some number. Now what is this one? 28 is some number subtracted from 12.
No.
That is not correct.
Yeah, that one's wrong. It's C. C's the wrong one. Why? Why is C wrong? Yeah, good job. What does it mean to be, the number subtracted from 12? That'd be 12 minus x or d, instead of d minus 12. That's reverse order, right? They got the order reversed there. When they say subtracted from 12, remember that does the order swap? No. Subtracted from 12 puts the 12 in the front. And that's wrong. Over here we see that the d's in the front, the letters in the front, not the 12. So that's kind of tricky. Yeah. All right. 4 subtracted from some number is 6. 4 subtracted from some number is 6. Subtracted from. What does that mean again? Flip it, right? And the sum number, that's always x. That's always your x, because you don't know it, huh? If I just say, hey, I'm thinking of some number, you don't know what my number is, so you just call it x. So these guys swap. The sum number and the 4 are subtracted, but reverse order. Everybody see that? 4 subtracted from means 4 goes at the back, doesn't it? That's the meaning of the English phrase subtracted from. Goes at the back. 4 does. Is, what does is always mean? Equals. That's my is right there. It's the equals, huh? If Johnny is 10 years old, that his age equals 10, right? Is equals. Is 6 equals 6. Like that.
That was a two-part question.
Oh yeah. Good point. So there's the first off, they want you to say what is the translation. So they want you to put on the left side x minus 4 into the box there. They already have the equals 6 part for you. They just want you to put the x minus 4 in the box. Yeah, so that'd be part 1. Good. Thanks for that. That'd be the part A or whatever you want to call it. And then you got to finish the second answer they want you actually solve this thing. Here's the wall. Let's finish solving it now that we know what the equation is. X is saying I want to be alone. So what do we do?
Plus 4.
Plus the 4. On both sides, x is 10, right? These 4's cancel. X is 10. That's the answer they want in part 2. They want the 10. Is that good? Questions on that one? So subtracted from goes at the back. Huh? Whenever they say subtracted from, that number goes at the back. All right. Give that one a try. Try that. And they want you to write an equation first off, and then they want you to solve it. So here, I'll write it out as well. 3 more. 3 more than n is 8. More than n is 8. So try to write an equation there. Here's the equals, right? The is 8 equals 8.
Yes.
So then the 3 more than this is there's the wall. So the left side is what comes before the is, and the right side's what comes after. 3 more than in. What is that? 3 more than in.
3 plus.
Yeah, 3 plus in, or you could write in plus 3. Have you noticed the order of adding doesn't matter, but the order of subtracting does, right? Have you noticed that? Think about numbers. If I go 7 minus 2, is that different than 2 minus 7? Does the order matter? Well, how about if I add them? If I add them, does that order matter if I'm adding them? No, it's 9 either way you do it, huh? Order of adding doesn't matter. But what if you subtract them? That matters, huh? This one would be positive 5. This one would be negative 5. So the order of subtraction we got to be careful with, because that makes a difference. But the order of adding, I never even give it a thought because it doesn't matter. So with that in mind, over here, if you put n plus 3 or 3 plus n, it's the same thing either way. It's all good. All right, so n wants to be alone. What do we do next? So there's the first thing they want. There's the first answer they want is they want that equation. They want you to write that. Now, what is the second answer they want? We got to solve it. How do we solve that equation? Good. Subtract the 3 from both sides. N is 5. N is 5. We good there? Questions on that one? Are these pretty comfortable? All right. Choose the right translation. All right. 9 less than some number is negative 22. Give that a try. See if you can turn those words into an equation. Or they already have, huh? See if you know which equation. Give you a second. Don't say it out loud. Give everybody a chance to think about that. Which of those is it? Okay, so 9 less than some number, it's C, isn't it? Because 9 less, 9 taken away from the x, is negative 22. Good on that? All right, let's keep moving. Oh, they wants to solve it too?
Can you solve D?
Not till next section.
Okay.
Yeah, we have to learn a little bit more. You're right. D's got a little trick to it. Yeah.
But we do have to solve that.
They do, yeah. So let me go back and actually finish. So it is C, and now let's actually solve C. Yeah, how do we solve for x that won't be alone? So what do we do? Add the 9 to both sides, and then use calculators at minus 13. There we go. Good? All right. So let's try this one. Kawan is playing a dice game. To earn points, he needs to correctly add up the total value of 5 dice he rolls on each turn. If he has a total of 21 on 4 of the dice, what does the 5th die need to be so that his score will be 25? Wow, it's easier just to, not use an equation. I mean, it's kind of like, makes it harder to use an equation, doesn't it? It's kind of silly. This is a word problem where it's better just to subtract and be done, right? I mean, this is kind of dumb. But anyway, We'll do their little thing. So they want us to turn all those words into an equation, which is not making it easier. It's making it way harder. But anyway, so it's basically saying, do you see which one of those equations is the same as all those words put together?
Yeah.
Which one is it? B as in boy, B? Right, because it's 21 plus some amount is 25, huh? That's what they're basically saying. You have a total of 21. How much more do you need to make 25? That's what they're saying. And we know the answer is just 4. Just subtract them. You don't need some fancy math equation, huh? Just subtract them. All right. That's a case of using too big of a tool for the job. Do you know what I mean? Like, you just have to put a little pic. You're trying to hang a little picture in your house, and you get a gigantic power tool. You know, you could just push the little nail in with your finger almost. You know, you don't need some big equation to solve that question. Just subtract, right? That's kind of a silly example they're putting forward. It's too big of a tool for that job. Now, there's times where you need algebra, and you can't just subtract. You read the words, and it's complex, and you need this big fancy tool called algebra. We'll get to those. But not this one. Just subtract, right? I mean, that's just silly. It makes the tool look stupid when you use it on a dumb little job, right? All right, let's see here. Let x, that's a lot of words. Let x represent the unknown in the following problem. Write an equation that describes the situation and then solve the problem. In a week, so here's where it actually begins, right here. In a week, a local computer store received 20,000 more from the sales of software than from the sales of computers. Receipts for the sales of software were 42,000. What were the receipts from computer sales?
So computer sales is X, right?
Yeah, computer sales is X. Yeah. Well, in the end, they just want the answer. Yeah, so I'm not going to use that. Again, this is another one. This is overkill. This is a pretty simple little question. They're just basically saying 20,000 more for software than computers. So they got 20,000 more from software than they did from computers. And they got, what is it? Software was 42,000. So software's 20,000 more, and they got 42,000 from software. So how much do they get from computers?
62.
What's that?
62,000.
Well, careful. Let me say it again. Software's more. Software's more. So the other one's less. Right? Software's more, so computers are less. Software's more. Software's 42. So how do we find the other one? Subtract 20. And you get 22,000. Done. I'm not going to do some big fancy X equation and all that stuff. That's overkill. It's a power tool for a silly little job. We'll come to a point where we need the power tool. And then we'll see the use of algebra. But not here. This just makes algebra look stupid. Right? It's making the job harder. Just subtract them. Is that good? Is everybody okay with that? Right? Because software was the higher one, so computers were the lower one. So just subtract. All right, let's go to 3.2. So we're not going to get all the way through this, but let's just start at 3.2. So 4x is 32. There's our wall. And we want to solve for x. X is yelling out what x is always yelling out. I want to be alone over here. So how do we get x alone over there?
Divide by 4.
Good. Now how do you know this time that it's divide? Why isn't it subtract like it was on those other ones? Good. Yeah, does everybody... Let me give you two problems at the same time, which I think will be helpful. I'll say, or 4 plus x is 3. There's another problem. Let's do two problems at the same time. So this one over here is the one This is from the last section. This would be a problem like the ones from the last section, right? What did we do in that last section all the time? How did we get x alone all the time? Yeah, because, right, x is saying I want to be alone, and 4 is added to it. So how do you get rid of a 4 being added? You subtract it, right? So I would subtract 4 and get x is whatever, 28, right? But in this case, I'm not going to subtract 4. No, no, no. Why not? Well, because that 4 is not added. It's right up against x, which means times, doesn't it? Everybody see that? Right? When the 4 is right up against the x with no symbol in the middle, that means times. When two things are right next to each other with no symbol between them, if it helps you, you can put in a dot for multiplication there. That means 4 times x. So you can't get rid of that 4 by subtracting it. You've always got to do the opposite, right? It's always opposite. So what's the opposite of multiplying by 4? Dividing by 4. Yeah, these are gone. That gets rid of it, right? Doing the opposite, right? Always gets rid of it. But I have to do the same thing to both sides to keep the balance. So the other side's division. Yeah, 32 divided by 4? 8. That's our real answer on this problem. Does that make sense? So now we have to think about when something's multiplied, we divide it. So we're always doing the opposite of what's next to x, aren't we? If something's added next to x, we subtract. Something's subtracted, we add. Something's multiplied, we divide. We always do the opposite, and then we do the same thing to both sides to keep the balance. Is that good? Okay, so minus 7x is 70. Give that one a try. X is saying I want to be alone. Here's the wall. Now that's a negative 7. Is that 7 subtracted? Is that x take away 7?
No.
No, that's a minus 7 right up against x, which means times, huh? That's minus 7 times x. So it's multiplication. So the opposite of multiplication is division. We have to divide. Now, if I just divide by regular 7, I'm going to be wrong. It's not regular 7. It's got to be negative. Why? How do you know? Who decides these things?
You gotta do
The truth is on the throne. Here's the truth. If I just put a 7 down there,
you gotta do exactly.
the 7s would cancel, but the minus would say, I'm still here. And X is saying, I said I want to be alone. Get rid of that minus sign. I don't want that minus sign. You see, if you just do a 7, you're not going to get rid of the minus sign. It takes 2 minuses to make plus, and thus just x. And whatever you do to one side, you got to do to the other. So you divide both sides by minus 7. Does that make sense? Because 2 minuses make the plus or regular x, don't they? And then what's the other side? What is positive over negative? The other side's just got 1 negative, so it's negative, and it's 10. And now we're done. Is that good? So let me hold up for just a second. That's a little confusing. Let me write what we just did. I think that'll help. When you divide, always divide by the same sign next, bless you, the same sign next to x, right? There was a negative 7 next to x, so I divided by negative 7. But over here, let me try to clarify this. What if we had like x minus 7 is 70? What would I do? I would add 7 to both sides, and I would get 77. So when you add or subtract, always do opposite sign next to x. Yeah, that's important. Go ahead and copy that down. That's really important that you get that distinction, that difference.
Can you say it again?
Yeah. So whenever we're doing adding subtracting, we always do the opposite sign, don't we? But whenever we're dividing, we divide by the same sign. Because the dividing does the opposite for us. We don't need to make the sign do the opposite. That's why. Really, in both cases, we're doing the opposite of whatever's next to x. Is that saying too much and confusing you? In other words, in the if it's just added or subtracted, the sign is what does the opposite. So you got to do the opposite sign. But when you're multiplying, the dividing is the opposite. You don't also change the sign. The dividing is doing the opposite for you. You've got to divide by the very same sign. That will have an opposite effect. So you got to remember that when you're dividing, you always divide. I always say by the identical twin. Whatever is right next, this is the identical twins, these two. You always divide by the identical twin. Whatever is next to x, same sign, same everything, divide by it. Whereas when we add subtract, it's opposite sign. So that'll matter. That'll come up again and again and again and again and back and forth in both ways, and you got to know that really, really well on that. Is that good? Making sense? $12x is 55.2. So here's the wall. X is saying I want to be alone. So do we subtract 12 or divide by 12? Divide, because that 12 is right up against x. Multiplied. So the opposite of multiplication is division. Is it?
4.6.
Oh, 4.6? Thank you. 4.6. There we go. Questions on that one? Is that good? All right. All right, so 0.8x is 16. So x is saying I want to be alone. Try that one.
If I saw this in word form, it would be 80% of x.
Yeah, nice. 80% of is right was the right word too, because that means times. Of is times, so you got it exactly right. 80% of x is 16. So 80% of some crowd, 80% of the class got A's. 16 people got A's. How big was the class? That would be a word problem that would lend itself to this. 80% of what group is 16 people? If 80% of the class got A's, that'd be a lot of A's. Then how big was the group? Well, to figure that out, we divide both sides by 0.8, right? Because that 0.8 was times. It was right next to the x times. So we divide. Is it 20? Must have been 20 people in that class. Is that good? Is that making sense on that? Any questions? We good? Remember, we always do the opposite, right? It's always the opposite of whatever's next to x to get x alone. So there we have x over 2. Here, let me do that again. So x over 2. X divided, here's the wall, divided by 2. X is saying, I want to be alone. Good. Yeah, because the opposite of dividing by 2, so it's whatever's next to x home. We don't even look at the 10. We don't even care about what's, there's a funny monkey on the other side. We don't care. We're not even looking at that other side. We're just, all of our focus, like baseball, you keep your eye on that ball. We're just looking at that x, and we're saying x needs to be alone. What's going on with x? He's got a 2 dividing. So what's the opposite of dividing by 2? You multiply both sides. See the parentheses? Times. I'm multiplying both sides by 2. Not adding 2. The opposite of dividing is multiplying. Yeah. So these cancel. X is alone. What's the other side? 20. We're done. Does that make sense? It's always the opposite. Is this good? You guys feel comfortable with this? All right, so again, we're always doing the opposite, right, of whatever's next to x. So 4/17 x is minus 20. What a mess.
So you'll flip it.
Yeah, let me bring this down a line here. Yeah, good thinking. Exactly right. Yeah, so the deal is we have to get x alone, right? X is saying, I want to be alone, get rid of whatever's next to me so that I can be alone. So I'm not even thinking about that negative 20. My eyeballs aren't even going to that side. I don't care at all. All my focus, eye on the ball, here comes the pitch. I am looking for the seams, right? I am focused on that ball. So I am looking at that x right here, and I'm saying, all right, whatever is next to x, I've got to do the opposite. What's next to x? 4/17. What's the opposite? Flip it and put a 17/4. Right? Does that make sense? All my focus is on x. Do the opposite of whatever's next to x. So I'm going to multiply by the upside down, the reciprocal. The upside down, 17/4. Why? Because that'll cancel the 17s and cancel the 4s, and x will be alone. See how that'll take care of it? In one step, that'll put x alone. And then I finally look at the other side and go, okay, yeah. Whatever I do on one side, I have to do on the other because I've got to keep the balance. Got to keep them equal. So then, yes, you do have to put a 17/4 there as well. But that's just a second thought. That's not, the primary focus was the x. That makes sense on that?
And then you multiply.
Now we got to work out that right side. Yeah, so the left side's just x. Everything canceled on the left side is just x. Now, how do we do the right side? What does that 20 do? Does it go to the top and the bottom? What does it do? How do you know? What do you do when you got like a whole number? Good, you guys know. That makes me happy. Yes, it's over 1, huh? A whole number is over 1. So when you've got a whole number interacting with a fraction, you put it over 1, correct. And then, what can we do? Right, because it's really over 1, a whole number, you put it over 1. And then 4 goes into 20. 5 times, you cross cancel. 4 into 20. 5 times, and then multiply the leftovers. So 5 times, and it's negative. Don't forget that negative there. Negative, is that 85? 5 times 17?
Am I getting totally confused? Why is that negative 20 not jump?
Not jump where? To the other side?
To the bottom and become a positive.
Oh, power. If that was a negative 20, power.
Okay.
Good. Yeah, it's negatives in the power zone that jump, not base zone. That's a base negative. Yeah, good. Yeah, so many rules, huh? That's the trick. They all start to look alike.
So
Yeah.
power should never ever be negative?
Right. Well said. Yeah, so if we had something like x to the minus 20 in the power zone, I would not leave it. I would tell, oh, no, let him jump down. It's 1 over x to the positive or regular 20 like that. Yeah, negative powers jump. But negative, just normal numbers, they're fine. Just a base number. It's not a power. Yeah, remember I did didn't I talk about like the governor never takes me to lunch?
Yeah.
Right. So I'm trying to just fix in your mind the idea that there's power players and there's regular folks, right? I'm a regular person, and then there's governors and senators and power players, right? So, and I don't live in theirs. They don't invite me to their house for Christmas dinner, and I don't know any power players, right? So I don't live in their world. So that's how math is. There's power level things, and there's base level things. You want to think of those as two separate worlds. Two sets of rules exist in those worlds. Yeah.
How'd you get a negative 85? If you divided 4 divided by 20, and then that's 5?
Right.
Okay, and then what did you do?
And then the leftover 5 and 17 times.
You divided 5?
I divide. So dividing. Good question. Let's straighten out. I know because I'm sure you're not alone in being confused with what happened. Let me talk about it more slowly and generally. Yeah, you divide whenever you go from bottom to top. So the 4 and the 20, because that's division, right? For everybody, right? One thing over the other always means divide, huh? So the 20 over the 4, even though it's sideways, it's still over. It doesn't matter, it's still over here and down, right? The 4 is under a bar, the 20 is over a bar, so that's still top to bottom. That's still right. So I divide them and get the 5. Now the 5 and the 17, they're on the level. They're both top, so they multiply.
Oh, okay.
So the 5 times 17 made the 85, and the negative sign just stays there because he was there all along. Yeah.
Could I just cross multiply?
Yeah, that's what I did, the long way.
Oh, you just went 20 times 17
Yeah.
and then divided by the 4. Yeah, that's totally fine. It's a little harder. Your numbers will be a little bigger because 20 times 17 is 340,
Yes.
right? And then divide. That's fine. Then you got a calculator. You can do that. That's the same thing. I'm just keeping the numbers small. It's going to be easier to divide first because you get smaller numbers. It's what it is. It's reducing early instead of late. But either way is okay. Question?
So, going back to the second step,
Yeah.
4 over 17 times x equals minus 20. You multiply it, right? 4 over 17. If you move it over, it will be division, right? So it will be x equals minus 20 divided by 4 over 17. And
That's
then you
true.
ended up with 17 over 4, right? No.
Are you saying that you could write it by dividing on both sides?
I think I get what he's saying.
Yeah, because 4 over 17 is multiplying x, right?
Right. I think I get what you're saying. Let me write there. Are you saying look, it's 4 over 17 multiplied.
Yes.
So really, you're
X will be equal to minus 20
divided by.
4
Yeah, you're
over
saying,
17.
can't you just divide both sides by 4, something like that?
Yeah.
You can. You're right. That's another way to, which is a little more complex,
Yeah.
but it's true. Because then that's negative 20 divided by,
That's right.
and then what do you do with divide? Flip. So I just went straight to the flip. But you're totally right. Good. Good. You're grasping the rules. You're right on the money there. Exactly. That's another way to say the same thing. Good. I like that. All these rules, isn't that beautiful? The way all the rules agree. They fit. So if you follow the truth, however you follow it, you'll get to the right answer. I always like that about it. It doesn't matter about your style. Doesn't matter about how it looks. Is it true or is it false? You'll get to the right answer if you stay in the truth. Yeah.
Okay. Are we gonna finish this whole chapter?
The whole chapter, certainly not. Not even this section. 3.2. We won't finish 3.2.
Oh,
So be good with there. Negative 85, whichever way you get there. Let's see. So, negative 2/9 y is negative 8. So y is saying, I want to be alone on this one. Oops, scribble in here. So do whatever it takes to get y alone there. All right. So what are we going to do on this one to get rid of that minus 2/9? Multiply by the upside down, right? Is it negative?
Still negative.
Good. Yeah, you guys thinking right. It's got to be negative 9 halves, because then the 9s will cancel, the 2s will cancel, and 2 negatives? Positive or just regular y. See, if you don't if you don't do another negative, you'll have negative y. We don't want, remember y wants nothing next to it. So you gotta do negative, because two negatives make positive. Good so far? So the left side cancels it all out. Y says, great, I'm alone. That's what y and x always want. Now on the right side, how do we carry out the right side? What do we do when a whole number, negative 8, is interacting with a fraction? Over 1, make it look like a fraction. Put it over 1, and then reduce. Cross cancel, bottom to top, right? Bottom to top always divide. 2 goes into 8 4 times. And then after you cancel, the leftovers multiply. 4 times 9, 36. Positive, because 2 negatives make positive. There we go. Is that good? Feel like you're getting the hang of this? Is that good to there? Well, we've done a lot. Should we stop right there about halfway through 3.2? None of this is due until, like tomorrow, I just want you focusing on the test. So 3.1 will be due, what's tomorrow? Thursday. Not till Thursday. So you don't have to worry about this, because we have exam number 2 tomorrow. Exam number 2 is tomorrow, Wednesday. So just focus on that on test day. I don't want you to have any other homework. So 3.1, you can do it after the test tomorrow. It's not due till the day after tomorrow.
Are we
on
only
Thursday.
doing the test tomorrow, or are you going over more chapters?
Oh, no, yeah, no, I can't burn those other 3 hours. Yeah, no, I need those. Yeah, so those first 3 hours, we will cover a whole bunch more. In fact, we'll finish 3.2, and then 3.3 is the doozy. That's the hard one. That's when they're all mixed. 3.3 will mix the two.
3.3?
Yeah, so we'll finish 3.2, and we'll do 3.3 tomorrow, which is the big one. That's the mix. And then we'll take our test, the real test, tomorrow. So how about we take a 10-minute break, and then we'll come back, take the practice exam. And so I'll give you the practice exam in 10 minutes. And then, in fact, yeah, and then after that, I'll grade it real quick, and we'll go over it for the last hour, or hour and 10 minutes.